students, welcome to the lecture number 7 on hydrocarbons. We are basically discussing the hydrocarbon chapters that includes in your class 11 chemistry organic chapters, and in this hydrocarbon chapter we have already discussed different topics, very relevant topics that relates to your syllabus. That is, we have already discussed 6 lectures, 6 videos we have produced, and let us have some recap before going to discuss the topic that will be discussed in this lecture, that is the physical and chemical properties of the alkyne. In the lecture number 1, we have discussed about the very important hydrocarbon, that is the alkane. Alkane is basically the saturated hydrocarbon. And in that lecture, in the lecture number 1, we have discussed about the preparation of the hydrocarbons, that is alkanes, that in various ways we can able to produce that alkane. In the second lecture, we have discussed about the physical and chemical properties of the alkane. In the third lecture, we have discussed about another very important hydrocarbon, that is alkene. Alkene is basically a unsaturated hydrocarbons, and in that lecture we have discussed different ways by which we can able to prepare these unsaturated hydrocarbons, that is alkene. In the lecture number 4 and 5, we have discussed about the properties of the alkene. In the lecture number 4, we have discussed about the physical property and chemical properties, some of the chemical properties of the alkene. And lecture number 5, we have discussed remaining chemical properties, chemical reaction that have been undergo by this alkene we have discussed. In the lecture number 6, we have discussed about the alkyne. Alkyne is another very important hydrocarbon, unsaturated hydrocarbons that we have discussed, and in that lecture we have discussed the preparation of the alkyne. Also, we have discussed in this lecture that nomenclature, how do we able to name this organic compound, that is the alkyne, and also we have discussed about its isomers. So that are all we have discussed in the 6 lectures. Okay, now in this lecture we are going to discuss another important topic, that is the properties of the alkyne. Properties of the alkyne means that we will going to discuss the first physical property, then we will discuss the chemical properties. Okay, so this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So first we are going to discuss the physical property of the alkyne. So physical property we are going to discuss. If we compare the physical property of alkane, alkene and alkyne, what we find? We find there is a similarity. They fall in line. They fall in line means that there is a similarity in the physical properties we observe. First thing is, when we are talking about the physical properties, it is basically the physical state at the room temperature, how this alkyne exists. And we have also found that this exists in the 3 states of matters. That is, the first you can write the alkynes is in the gaseous state. Next, it alkyne in the liquid state. And higher, you can write the higher ones in the solid state, higher ones in solid state. Okay. So this hydrocarbon, that is alkyne, is basically exist in the three state of matters. Second points of the physical properties. Second point is its solubility. Is solubility. 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 Is solubility, if we see, that is same as alkane and alkene. It is insoluble in water. So we can write solubility not soluble in water. Not soluble in water. But it can be solved, it can be soluble in the organic solvent like ethers, benzenes, all those organic solvent, it will be soluble, but not in water. Third point, that is, it is slightly polar. It is slightly polar. Fourth point, that is very important, is boiling point, melting point, and density. It goes on increasing with the increase of the molecular mass. So it will goes on increasing with the molecular mass. With the molecular mass. Okay, so these are all the physical properties. And we will find that is more or less similar to the alkene or alkane. Next point that we are going to discuss is a very important point, that is the chemical properties. Chemical properties mean which type of chemical reaction it will going to undergo. So when we are discussing the chemical properties, we can divide this into the three ways. Number A. A is basically it is having the acid property. This is having the acid property. Second, it undergo the addition reaction also. Second point is addition reaction. Okay, and third point, that is it can also undergo polymerization. Polymerization that we have observed in case of alkene also, that is the small molecules will combine itself and we can find a bigger molecule, that is the polymerization. The process is called the polymerization. In this process we have observed that different types of products have been produced which has been used in day-to-day basis. It has a lot of usage that we understand, and here also in case of alkyne also you can see this type of trait, physical chemical properties of the alkyne. So first we are going to discuss the acid property. Acid property of the alkyne. What is this? Basically, this property is a very, very distinguishing property of the alkyne as compared to the alkene or alkane, because those two hydrocarbons do not show this property, but alkyne show this property when it has reacted with the active metals like sodium or sodiamide, it is going to produce the hydrogen or ammonia, whereas the alkene or alkane do not. So question arises, why it is so? why alkyne is show the acid property and at the same time the alkene or alkane do not. The reason behind it, if you see the hybridization of the carbon in the alkyne is sp hybridization. Sp hybridization means, suppose this is acetylene. This is acetylene. Here you can see this carbon is sp hybridized. As because of this is sp hybridized, means this orbital, sp orbital is highly electronegative as we compare with the alkene. Alkene, here you can see its hybridization, here it is sp hybridization, whereas in the alkene it is sp2 hybridization. sp2 hybridization, where in case of alkane it is sp3 hybridization. So what we find, that is the s character if the orbital goes on increasing as we goes from this side, from the alkane to alkyne, and that is why this carbon atom is highly electronegative. So it can attract the shear pair of electron towards itself. So this hydrogen atom can be easily be released and it will show the acid property. And this is the very important property by which we can able to distinguish this alkyne with the alkene or alkene. So we understand why it is so the acid property. It is basically due to the higher electronegativity of the carbon atom present in the alkyne as compared to the alkene or alkane. And another thing that you can see, all the hydrogen atom in the alkyne is not acidic. That you can easily understand from here. Here this is propyl. Okay. Here this hydrogen atom is not acidic, but this hydrogen atom is only acidic. Here in the ethyl you will find that there is a two hydrogen, both are acidic, whereas in the propyl only one hydrogen atom is the acidic. There is a test by which, by using this exploiting the property of the acid property, you can able to distinguish. Sometimes question arises, how do you distinguish? Suppose question is this: ethyl, you have been given one compound is ethyl and other compound is ethene. So how do you distinguish between these two hydrocarbons? This can be distinguished by this way. When ethyl is reacted in cuprous chloride, CuCl2, ammoniacal cuprous chloride, at that time it is this hydrogen atom, due to it is acidic, this hydrogen atom is going to replace and it is going to produce this. This is the copper acetylite, and it is given a red PPT, red precipitation, PPT in the solution, and from this you can able to understand there is a presence of ethyl, whereas ethene or ethane you cannot able to see this reaction. So this is a very important reaction, very important property of the ethyl by which we can able to distinguish from the ethyl and ethane. This type of question you can ask. So this is the acid property, and in this acid property you can observe that there is a replacement of the acidic hydrogen with the active metal. Now if we want to make a order of acidic property of this ethyne, it will more than ethene and that is ethane. Now one question arises. Question is, there is a isomers of butane, 3 isomers. How do you able to distinguish these 3 isomers? What are those 3 isomers? Now one, that is but 1 I. Another isomers is but 2 I, and third isomers is 2-methyl propyl. Methyl, that we have to not propyl, that is you have to see. So third isomers that we will discuss later on. Now these 2 isomers, that is butane has 2 isomers, and these 2 isomers can be distinguished from these properties also. How it is? Let us understand. This is one butane. When it has been reacted with the cuprous chloride in the ammoniacal cuprous chloride, it is going to produce this. It will also, you see, the red precipitation, and it is copper 1 copper 1 butanite. Name of the compound copper 1 butanite. You will find the red precipitation. But in case of but2I, this is but2I, you will not find this reaction. Why? Because there is no acidic hydrogen. So this type of question will ask, how do we able to identify the different isomers of the butane, right? So in this way, by using this acid property of the alkyne, we can able to make this. You can able to distinguish it. Okay. Now we are going to discuss another very important property, that is the additive property. Like alkene, it also shows the addition reactions that we are going to discuss. Reaction that we are going to discuss, the addition reaction. Addition reaction, like alkene. In the alkene, we are also observed addition reaction. This is basically electrophilic addition reaction, and this addition reaction is occurred, has been made with, in principle, with the Markovnikov's rule. This addition reaction, first we are going to discuss different additives, that is dihydrogen, halogen, halogen acid, or we can say water also can be added in the specific condition. That we are going to discuss. First we will discuss the addition of dihydrogen. Addition of dihydrogen. In this reaction, as it have the three bond, one triple bond, three bond, that is, here you can see it is having the one triple bond in the ethyne. So when we are going to add this in presence of catalyst, platinum, nickel or palladium, what is going to happen? There will be the two molecules of the hydrogen will be added to it. So it is going to produce, first it will going to produce this. This is ethyne. This is ethyne. One molecule is added and it is going to produce ethene. Here one double bond still present. Further it will again, this reaction will going to happen. So it is going to produce the ethane, saturated hydrocarbon. So you can see there is a two molecules of hydrogen has been added. Similar fashion, you can have the addition of halogen. Halogen can be added also like hydrogen, that what we have observed in case of alkene. Alkene maybe we have observed it. So now we are going to discuss the addition of halogen. In this case, we have taken one hydrocarbons, that is CH3, C triple bond, CH. This is propyne. When propyne is added with bromine, it is going to produce this product will produce, that is C beer CH beer. Then again another molecule of bromine will be added and it is going to produce CH3. This is 1,2-dibromo propene. And when another two molecules will be added, so another molecule of bromine will be added, it is going to produce this beer, and it is being saturated CH, beer and beer. So it is going to produce 1,1,2,2 tetrabromo propane. Okay, so we understand the addition of the halogen to the propyne. Basically there is a production of the carbocation, and in this way next will be bromine will be divided into plus electrophile and another is nucleophile. So it is first electrophile will attack here. After that, when this carbocation is formed, at that position the nucleophile Br minus will be attacked there. That is all for today's lecture. In this lecture we have discussed about the physical and chemical properties of the alkyne. That in the chemical property we have discussed the acidity of the alkyne, and in the other addition reaction that has been undergo by this alkyne, that is addition of dihydrogen and addition of halogen we have discussed. And the next lecture we are going to discuss the remaining chemical properties of the alkyne. Thank you very much for watching.